Hello everyone, welcome to question 13 of Placement Test Series 1 on pointers and arrays. This is a slightly advanced question. Now here we have an array A of 5 elements with values 0, 1, 2, 3 and 4. Now assuming that the array starts at address location 100, the next element will only be stored at location 104 because it is a 32-bit compiler and every integer is going to take 4 bytes each. So 0 will require 4 bytes and then followed by 1 which will be another 4 bytes. So 2 can only be stored starting at address 108, 3 at 112 and 4 at 116. Now we've already seen in question number 12 that the name of the array is itself a constant pointer which points to the starting element of the array. Since 0 is the starting element of the array, the name of the array, which is A, points to the starting location, which is nothing but 100. Now in the next line we see that we have int star p and square braces open and close. Now with the square braces we know that this is an array, and with the star we know it is a pointer. If we combine both, so it can be read as P is an array, so we move forward and then we move backward. So P is an array of pointers to integers. Now there are some rules to decide how to go forward and then come backwards. We're not going to go into those rules now. And we see that the elements of P are nothing but the first element is A, and we see A is 100. So we go and fill the first element as 100. Then the next element is A plus 1. Now 100 plus 1, if we remember pointer arithmetic from question 12, whenever we increment or decrement a pointer, it always does in steps of the type or the size of the type it is pointing to. Now since A is pointing to integer and an integer is of 4 bytes each, so any increment you do on A will always move it in steps of 4. So A plus 1 is nothing but 104. Basically, it's indicating that if A is here, you want to go and access the first element, which is nothing but address location 104, and that's put here. And then A plus 2, you're indicating I want to read the second element, and hence 108, and then 112, and then finally A plus 4, which is nothing but 116. Now, the same rule applies here, assuming that 100 is stored starting at address location 200, then the next address is going to be 204. Now, why 204? We know that these values are pointers, and in a 32-bit system, a pointer also occupies 4 bytes each, which indicates if this is going to be 4 bytes long, then the next element can only begin at 204, and then 208, 212, and 216. The same rule applies again. If P is an array of pointers, the name of the array is itself a pointer which points to the starting element. So P value is nothing but 200. Now the third line is a little tricky, where I see int double star ptr equals to P. So first let's draw the memory block for ptr. Now let's try to decode what this double star means. For starters, ptr is a pointer to an integer. The two ways we can try to understand this. One way is to see how many dereferencing I require to reach 0 or any integer in this block. So if I dereference 200 once, star of 200 is basically value inside this 200 block, which is 100. And then star of 100 is basically value inside this 100 block, which is 0. So I require two dereferencing from this value ptr to reach to this value 0, and hence we require two double stars here indicating ptr is a pointer to an pointer. The other way to see it is we already know that P is an array of pointers, and the name of the array is also a pointer. P becomes a pointer to an pointer. And if we want to equate ptr to P, I need to have ptr of the same data type as P. And now we will do some arithmetic operations on ptr. Please note the reason why we've used this line and not straight away gone and did P++, because the name of the array is a constant pointer, which means on a constant pointer we cannot go or increment or decrement those values. The reason being is once p moves anywhere else than the start, we do not know what is the start of the array, and hence that's not allowed. And sometimes in interviews you do end up getting this, where in the name of the array is incremented or decremented, and one of the options is compiler error. So the compiler is going to throw an error that this is not allowed since p is a constant pointer. Right, so we come to this line wherein we see ptr plus plus. Now ptr plus plus, since ptr is pointing to a pointer, because 200 is pointing to 100, so 200 is a pointer, so pointer is pointing to a pointer. And we know that by pointer arithmetic that a pointer always increments or decrements in steps of the size of the type it is pointing to. So since 200 is pointing to a pointer, so the size of the pointer is 4 bytes, and hence if I do any increment on this, it will increment in steps of 4, and this value is going to become 204. Now we come to the printf statements, wherein first I print ptr minus p. So we just follow the values. So 204 minus 200. If I have to go from 200 to 204, I know 200 plus 1 is nothing but 204. So take 200 that side. So basically 204 minus 200 is nothing but 1. The next is star ptr minus 8. So that is, so value at 204 is 104. So 104 minus 100 again going to be 1, because between 104 and 100 there can be only one integer. And by pointer arithmetic, since pointer always increments or decrements in steps of the type size it is pointing to. And then finally star star ptr. So star of ptr, so we're dereferencing location 204, we're getting 104, and then we do again a star of 104 and we dereference this location, so we get the value 1. Now followed by the next line. Now we have star ptr plus plus. Plus plus has a higher priority than the star. So what it does is, first it does ptr plus plus, and then it dereferences this location star of ptr. Need to remember that ptr is plus plus is a post increment operation, which means first it will use the value as it is and then increment it. It will first dereference star 204. So when I do a star of 204, I get basically 104. And it's just like writing 104 semicolon. Does it mean anything? C just ignores this statement. After it does it, it will change 204 to 208. And now again we go back to the printf statements, where in first we do ptr minus p. So we are first doing 208 minus 200. Now between 208 and 200, we know that we can go to 208 from 200 in 2 steps, right? Because it increments in steps of 4. So hence 208 minus 200 will give you value 2. The next is star ptr minus 8. So we need to dereference location 208, we get 108. And 108 minus a, and a is 100. So 108 minus a 100, again, because these are pointers to integer, we know between 108 and 100 there can be only be 2 integers. Answer is 2. And then finally star star ptr. So we need to dereference 208 and we get 108, and then we need to dereference 108 and we get the value 2. So the next printf has resulted in 2, 2 and 2. Now the third part, star plus plus ptr. Now here, since plus plus has anyways a higher priority on ptr, so and we know that it is a pre-increment operation, so first it changes the value and then it uses it, right? So plus plus ptr, so 208 plus plus, that becomes 212, and then I do a dereference on 212, so I basically get 112. So it's again like writing 112 semicolon. Does it really mean anything? No. Compiler is just going to say 112 semicolon, you're not doing anything, I'll just ignore this statement. And then we have printf, again ptr minus p. So we are doing 212 minus 200. So it's again 212 and 200 are pointing to pointers, and since pointers are of 4 bytes each, so between 212 and 200 there can be only be 3 pointers, and hence the first answer is 3, followed by star PTR minus A. So star of 212 we get 112, 112 minus 100, right? So we are doing this. Now we know that these pointers are pointing to integers. So between 112 and 100, there can only be 3 integers of 4 bytes each. So the next answer is 3. And finally, dereferencing PTR twice. So star of 212. So basically, I'm saying value inside location 212, which is 112, and then a star of 112. So that is value inside location 112, which is nothing but 3. So the next answer is also 3. And the final one is plus plus star PTR. Now here we see that star is touching PTR, but plus plus isn't. So this expression is more like plus plus and bracket open and star PTR. So PTR was 212. Star of 212, I am at this location and I'm doing plus plus on this, which will change the value to 116 because these are values which are pointing to integers, and if I do 112 plus 1 it should change it to 116. Please note these are plus, post and pre-increment operations. Always remember whenever we're doing any pre or post increment or decrement operations like minus minus a, it means a equals to a minus 1. A new value is updated inside the variable. So it's basically updating a memory location. So do not forget to update the memory location. PTR minus P. Now PTR is still 212. 212 minus 200. It's the same like the last question. So we go and replace it with 3. Then star PTR minus A. Now this is where the answers change. So star of PTR, now it is not 112 but it is 116 because of this statement. So 116 minus 100, we know that there can be 4 integers between 116 and 100 and hence the answer is 4. And star star PTR, dereferencing 212 we get 116, and dereferencing 116 I get value 4. I hope you all liked the video. Please do share and subscribe if you liked it, and please leave suggestions in the comment box below. Thank you.